Okay. Okay, Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al hazna idza sitta sahla. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. Okay, testing. Can you hear me?
Yes, doctor.
Okay, so let's proceed. Before we go to the example of this lecture, is there any question from you regarding this equilibrium 3D? Any question? Regarding the reaction, 1 unknown, 2 unknowns, 3 unknowns, 4 unknowns, 6 unknowns, 4 unknowns, 5 unknowns. Okay. Any question, guys?
None from me, doctor.
Okay. So to everyone, is there any question? If no, can I proceed to the example 1? Okay, let's proceed to the example 1. Okay, so this is the example 1. Very simple. You can assume this system like your elbow, shoulder joint. Okay, you can assume this system like your shoulder joint. Okay, shoulder. Okay, so the system shown in the diagram is in equilibrium. You have to determine the tension in cable AAC. There are two cables there, AC and AD. You have to determine both of them, and the reaction at the ball and socket joint at O. Okay, so you have to determine cables, the tension in cables, and also the reaction at O. Okay. Okay, for the calculation, for the solution, again, I like to ask this question: what is the first method? What is the first step that we have to do?
The FBD.
Yes, correct. So which body you want to select? Which member you want to select? Which member? Anyone? OAB. Yes, correct. So the member that you have to choose is OAB. Okay. Then the first step, of course, FBD. Okay. You have to draw the geometry of OAB first. Okay. Then you have to determine all the external forces, internal forces, the unknown value of reaction, okay, and also the cable, okay, TAC and TAD. Okay. So this is a basic thing. You have to draw the OAB member first, like this, for example. Okay. And then you have to put all the internal and external forces. For example, I taking the cable first at this point A. Okay, like this point, this one, like this one, and the V, which is this one is TAC, and this one is TAD. Okay, and put all reaction at point O. Okay, the axis is given there, where the is X, okay, OX, OY, and OZ. Okay, and then don't forget to put another external force here, 840 Newton. And of course, don't forget to put the dimension, okay? Here, 0.6, here, 0.4, okay? As simple as that. As simple as that. Okay, so actually you can make more complex of FBD, okay? More complex FBD. You have to put the dimension of the cable, okay? Like I will show you in the next slide, which is like this. Okay, so this is your FBD, including all forces, all the reaction, and also the the diameter. Sorry, the dimension. Okay, including the axis X, Y, and Z. Okay, so in examination, in test, in any assessment, assignment, or so on, you have to include the FBD like this. You have to draw the FBD like this. Okay, all right. Okay, once you have this FBD, what is the next step? Anyone? What is the next step?
Determine AC and AD.
Sorry, can you speak louder?
Determine AC and AD.
Okay, determine the AC and AD. Yes, correct. You have to determine TAC and TAD in terms of IJK form. Okay, so because this is 3D, so you have to make sure that the equation is in IJK form. Okay, for all of them. For 840 Newton, for TAC, for TAD, and also for the O reaction there. Okay, reaction and O. Okay. Okay, since we have 1, 2, 3, 4, 5, 6, sorry, 5 only, OY, OX, OZ, TAC, TAD, means we have to determine at least 5 equation. Okay, 5 equation to solve this problem. Okay, so we do have this unknown, this unknown, this unknown, this unknown, and this unknown, which is 5 unknowns. Okay, so you have to determine, you have to develop at least 5 equation to solve the problem. Okay, so okay, again back to the initial part, which is we have to determine the TAD and TAC in terms of IJK form. Okay, so I like to ask, what is the method to determine, what is the method to develop TAC and TAD? You have learned this before. I think lecture 3 or lecture 4. How to determine, how to develop TAC and TAD in term of IJK form? Yes, correct. Coordinate method. Okay, coordinate method. Okay, so you can use the coordinate method to determine TAC and TAD. Okay, in term of IJK form. Okay, before that, I want to ask to make sure that you understand. Okay, to make sure that you understand. Not us. I think maybe I can explain it. I brief the idea of solution. Okay, the idea of solution. So basically, what you have to do is, the first thing you have to draw FBD. The second thing is you have to determine all forces in IJK form, and then once you get the forces, the reaction in term of IJK forms, then you can develop 5 of 6 equation from the equilibrium system. Okay, so we do have the equilibrium system of Fx equal to 0, Fy equal to 0, okay, f z equal to 0, okay, and then the moment, okay, moment o, for example, equal to 0, okay, and then what else, okay, moment x, for example, okay, equal to 0, and so on. Okay, this is the equation that you will develop later on. Okay, this is the basic idea. Okay, for example, okay. All right, it is not necessary to find the axis for the moment. Okay, you can get it from a point as well, like this. Okay, you can develop a equation from the another point, which is point E, for example. Okay, like this. You can develop the equation from another point as well. In this case, we do have B. Okay, you can go around, you can play around with this different moment. Okay. Okay, this is basic idea. This is the five, at least five equation that you have to develop to solve the problem. So in order to develop this equation, you have to determine the IJK form. Okay, you have to translate the forces. Okay, you have to translate the forces into IJK form. Okay, all right. So for TAC, okay, for TAC, okay, you have to determine dx, dy, and dz. Okay, so what is the dx for TAC? Anyone? dx, what is dx?
Minus
Anyone?
0.6.
Yes, correct.
0.54.
Minus 0.6. It's from here, okay, to this plane. Okay, so this is the value and negative sign because from right to left. Okay, okay, 0.6. Okay, what is the dy?
Positive 0.7.
Yes, correct. What is dz?
0.6. Positive.
Yes, correct. So you will get d from this one. Okay, how much it is?
1.1.
1.1. Great. So once you have the ds, dy, and dz, you can put all those information into the equation. So since we don't have the TAC, you can put TAC, okay, dx over d, okay, negative 0.6 over d is I, okay, and then plus TAC 0.7 over 1.1 G, and the last one is TAC 0.6 over 1.1 K. Okay, you will get the first IJK form, okay, for the TAC. And then for the TAD, same goes to TAC, where you have to determine dx, dy, and dz. So what is the value for dx, dy, dz? Someone? Someone? What is the value?
0.6.
Negative 0.6, correct. Dy?
0.2.
Yes, correct. Dz?
Negative 0.3.
Yes, correct. And then you will get d. What is the value for d?
0.7.
0.7. So you can write down the TAD in terms of IJK form, okay? Negative 0.6 over 0.7 I, okay, plus TAD 0.2 over 0.7 G, plus TAD in bracket negative 0.3 over 0.7 K. Okay, this is your TAD in terms of IJK form. Okay, we got TAD, TAC. Okay, next one. Next one, which is this value. So this is straightforward. What is the value? What is the equation for 840 Newton in terms of IJK form?
minus G.
Sorry?
Minus 840 G.
Yes, correct. So this is the 840 Newton in terms of IGK form. Okay, and don't forget we have another one which is point O. Okay, I put it O. Reaction. Oops. 8O. So O you can determine straightforward like this. Okay, I plus O Y G plus O Z K. Okay, so you have all those equation in terms of IGK form. Then you can apply the equilibrium system, this one, to develop the equation. Okay, all right. So let's say you are taking fx equal to 0. So you add all the x component for O, x component for this one. Since this one, there is no x component. No x component. So no need to add this one. And then TAC, we do have x component as well. TAD, we do have the external component as well. Okay, you will get first equation. Okay, so I will straightforward show you the solution for the equilibrium system. Okay, this one. Okay, so this is the first equation, this is the second equation, this is the third equation. Okay, this is the summation of fx, summation of fy, summation of fz. Okay, okay, so fx is from the x component. Okay, this, okay, plus this one plus this one. Okay, you will get this one. Okay, and y component, this one, y component plus this one plus this one, and don't forget for the 840, where is the 840 in this slide? This one. Okay, okay, this is the y component. So you add all the y component, you will get this one. Oh. Okay, and the last one is the z component. Okay, the z component. Okay, which is this one. Okay, this one, add this one. Okay, and sorry, this one. Okay, so this is the z component, and you will get the z component like this. So you have three equation already. Okay, you have three equation already. Okay, so where is the another two equation? Two or three equation? It is coming from the moment. Okay, it is coming from the moment. Okay, so moment. Okay, the first thing that you have to calculate is, of course, the moment where is the point will eliminate a larger number of unknown value. Okay, where the point will eliminate the larger number of point. Okay, so of course in this FBD, the larger number of unknown is located at point O here. Okay, okay, so you have to taking a moment about this point O. Okay, you have to calculate moment about point O. Okay, so basically you already know how to calculate moment in 3D. Okay, just apply what you have learned before. Okay, and let me go back to the FBD. Okay, from this FBD actually, okay, you will use three force. The first one is TAC, the second one is TAD, okay, and the third one is 140 Newton here to calculate moment about point O. Okay, so to calculate moment about point O, you have to utilize these three forces. Okay, so back to the slide. The first one is, of course, this one. the first force. Okay, the second one is TAC. Okay, and the third one is TAD. And of course, R, the shorter distance, the perpendicular distance, the shorter distance, okay, is different for 840 and also TAC, TAD. Okay. So TAC, let me erase this one. Let me erase this one. Okay. Okay, for the TAC and TAD, the R is from here to here. Okay. Okay. The R is from here to here, from O to A. So this is your ROE. Okay. And of course, there are more than more than one of the R. Okay. It can be from O to A, and also it can be from O to this point. Okay. R, O, C. Okay. This point, R, O, D. But again, as I remind you last time, okay, you have to choose the simplest R. Okay, in this case, the simpler R is located at here. Okay, you choose 0.6, just 0.6, positive 0.6, positive 0.6 I. Okay, and then the other R is actually for 840 Newton. Okay, for the 840 Newton. Okay, from O to here, point B. So this one is ROB, and the value is 1I. Okay, 0.6 plus 0.4 equal to 1I. Okay, so you have the R. Okay, you have the R, ROA and ROA, ROB, ROA, ROA. Okay, then substitute all those information, okay, ROA into the equation. You will get the moment, the first moment for this one. Okay. Okay, make sure that you use cross product. Do not use dot product to solve the moment. Okay. And then for the TAC, you substitute ROE into education. TAC is already there. Okay, it's already there. Okay, do the cross product, you will get the second value of moment for point E. This one. Okay. This one. Okay, but in terms of unknown value. Okay, in terms of unknown value. Okay, so the last one is TAD. Okay, same ROE. Okay, substitute into the equation. Okay, TAC is there, then you will get this one. Okay, for detail you have to do exercise. Okay, I will explain only a brief solution. Okay, once you have all those information, okay, once we have those all information, you have to apply the equilibrium system of moment equal to 0. Okay, you have to get the x component, y component, and z component. Okay, all right. So for this case, let me go back. Okay, for this case, the moment is only for this one, which is z component. Okay, what is it? Okay, this one for y component and this one for z component. This one is y component and for this one is z component, meaning that there is no x component for the moment. So meaning that you have two equation, another two equation that we are looking at, we are looking for. Okay, there are two equation from here, which is a y component, the number 4 equation, and z component of moment, which is equation number 5. Okay, so 1, 2, 3 equation from the equilibrium system of forces, and another two equation for the equilibrium system of the moment, but y and z component only. Okay, so you determine the y and z component. Okay, so in this case, in this example, there is the number 4 and there is the number 5 equation. Okay, so this one 0.327 is actually for the y component plus this one. Okay, 0.327 plus 0.25. Okay, this is the y component. Okay, this is the z component. Okay, z component, y component. Okay, so once you have the 4 and 5 equation, you can solve this first. Okay, because there are two unknowns only. You can get TAD and TAC from these two equations. Okay, from these two equations. So substitute 5 into 4 or 4 into 5, then you will get TAD and TAC for the final answer of TAD and TAC. Okay, so you already solved the first problem, which is determine TAD and TAC. Okay, once you have this value of TAC and TAD, you substitute into all the earlier three equation that we developed, okay, to get the reaction value. Okay, substitute here TAC, TAD, TAC, TAD, TAC, TAD, okay, to get the value of OX, OY, okay, you will get OX, OY, and OZ. Okay, that's it. That's it. Okay, do you clear? Any question? Any question?
No, doctor.
No. Are you sure no question?
For me, no, doctor.
Okay. So if no question, let's proceed to the exercise. Okay, announcement. Please do this EPPP, online evaluation for teaching. Okay, make sure that you do it. Okay, not only for me, for Dr. Aisha as well. Okay, for Dr. Aisha and me. Okay. All right. So this is the exercise. Okay. Let's do together. Let's do together. Okay. So the question from the exercise, rod OA of negligible mass is supported by cables A, B, and EC. Okay, there are two cables there, A, B, and AC, and loaded with forces as shown in the diagram. So there are two forces, external forces, which is 750 and 500 Newton. If the rod is supported by a ball and socket, okay, ball and socket at point O here, okay, determine the tension in cable A, B, and AC, and the component of the reaction at O. Okay, looks like similar from the previous example, but this time around we do have two external forces in different geometry, in different condition of geometry. Okay, so there is no solution yet for this exercise. We have to do it together. Okay, so again, what is the first step that we have to do? Ya, FBD lah. Ya, FBD dah tahu jawapan kan, senang juga. Okay, let me do something. Okay, you can draw it. You can draw the FBD in your sheet of paper right now. Okay, while waiting for me to do something. Okay, you can draw the FBD now. Please do it now. What kind of rigid body, which one you want to select for drawing the FBD? Okay. So which rigid body you want to draw? Which rigid body you want to draw? Yes, of course, very easy, very straightforward, which is OA. So draw the geometry of OA first. Okay, draw the geometry of OA first. Okay, OA, OA, OA. So this is your ball. Okay, and this is the rod. Okay, and then sorry, let me redraw again. I redraw it here lah. Okay, so from this geometry, you have to determine the external forces and also the internal forces. Okay, internal forces. So point E, point O. Okay, we do have the reaction at O, which is OX. Must follow the axis, the given axis there. Okay, if no sign for the axis, you can assume the first axis. You can assume it. If the axis is given, then you have to follow the given axis. Okay, so this is the reaction. And then this is the cable, one attached with the X axis from E to B. Let me draw like this. This is TAB. Okay, another one is like this. This one is TAC. Okay, and don't forget to put the external forces there, which is 500 Newton. Make sure that you understand the plane. This is the plane. Okay, and this is plane as well. Okay, so make sure you understand the plane. 500 Newton here, and also this one, 750 Newton. Okay, and the last one is of course the dimension. Okay, put all the dimension. Okay, so you have this one. Oops. Oops. You have this one, 4. Okay, you have this one, 7. Okay, and I think that's it for the dimension. Okay, that's it for the dimension. Okay, if you draw like this, you will get full mark lah, of course. Okay, for the FBD. Okay, so this is your FBD. Once you have the FBD, then you can determine all the equation, TAB, TAC, O, and the 500 and 750 Newton in terms of IGK form. Okay, in terms of IGK form. Okay. Let's we do for the TAB first. TAB, What is the dx, dy, and dz? Anyone? Dx, dy, and dz.
dx for Dexter.
Sorry, again?
For dx
Yes.
negative.
Oh.
Yeah.
Negative or positive?
Positive.
Yes. Dy.
7.
7. Yes. Negative or positive?
Positive.
Wrong. The answer is negative.
Yes, sorry, negative.
And dz?
Dz.
0 for TAB.
Mm.
dz0, yes. So what is the d value? Someone help me to calculate.
Eight, doctor.
8.
8.06.
Okay. 8.06. Okay, then you can draw, you can write the TAB in terms of IGK form. So since, oh, sorry, alamak. Okay, since there are two components only, so just put two components of X and Y. So we do have a TAB in bracket 4, okay, I, and Y component is plus TAB in bracket Z minus 7 over 8.06 G. Okay, so this is your TAB in terms of IGK form, yeah. Okay, in terms of IGK form. Okay, let me do something. Wait, let me do something. Keep. So I copy this one. Copy as many as I like. So I erase. Alamak, dibuang semua pula. Okay, never mind. I draw. I just erase all those. Okay, this one is small. Okay, so let it be. Okay, once you have TAB, you have to get TAC as well. Okay, you have to get the TAC as well. So TAC, you have to determine dx, dy, and dz as well. Okay. So from here, what is the dx for TAC? Dx for TAC. Ah, great, Li Jiaying. Dx is 4. Yes. Dy is -7. Yes. Dz is -4. Okay, correct. So please help me to calculate D. And D is 9. So write the TAC in terms of IGK form. Okay, TAC 4 over 9 I. Sorry, I. Okay, plus TAC -7 over 9 G. Okay. Next is TAC -4 over 9. Okay. Okay. From here, you can simplify the equation actually. Okay, you can simplify the equation. Okay, next one. Yep. Okay, next one. So take the easiest way, the easiest one, which is reaction in O. Reaction in O, easy lah. Okay, straightforward. O equal to OXI plus OYJ plus OZK. Okay, and then 750 and 500. This one very tricky. Okay, you have to be careful. Make sure that you determine the correct IGK form for both 750 and 500 Newton. Okay, let me take 750 first. Okay, 750 first. Okay, so from this figure, what you can understand, how many components is there?
2.
Yes, correct. Two, only
Okay.
two. Which part? Which component?
JK.
Z and X.
No, Z is correct.
Z and
I and J.
yeah, Z and
750 Newton.
and K, J and K.
Yes, Z and K only. There is no X component at all. Okay, there is no component S for X. So you can draw like this. Okay, okay. This one is Z. This one is Y. Okay, so your force is like this, and there is the angle. Okay, 750 Newton. Okay, so you can resolve this value. You can resolve this value. So you will get, okay, let me write here. You will get the value for 750 Newton. Okay. For the Y component should be 750 Newton sine 60 PSJ. Okay. And the Z component 750 cos 50 P. Okay. This is your 750 Newton in terms of IGK form. Okay, make sure that you understand the forces belong to which plane. Okay, the last one for the forces is 500 Newton. Okay, 500 Newton. 500 Newton. Okay, so how about 500 Newton? How many components there?
Minus 500 I.
Only one.
Yes, one on X.
Yes, correct, correct. There is only one component for 500 Newton. Okay. You can see the plane there, the purple line that I draw for you. The purple line that I draw for you. Okay. So it is on the plane, okay, on the plane of the XZ plane. Okay, XZ plane. So there is no component for Y. There is no component for Z. Okay, only one component, which is X component. So you can put just negative 500 Newton, negative 500 I. Okay, 500 I. Okay, right? Okay. Okay, right now I need your help. Okay, to simplify this equation. 4 over 8.06. How many? How much? This one.
0.4.
Can you speak louder, please?
0.9.
496. 3.5.
0 point
496.
496 I. How about another one, which is sorry, I put it TAB first. Minus 7 over 8.06. How much?
Negative 0.868.
Negative 0 point
868.
TAB G. D is I. Okay. Let me read the question from Lee Jia Ying. Doctor, we require to determine the 700 Newton in 2D. In Z and X direction. Dimension or 3D, Z and Y direction. Lee Jia Ying, the answer is the second one, which is the dimension. The 3D dimension, actually 3D dimension, but I simplify it like this lah. I simplify it like this, okay, to better give the solution, okay. So it is still 3D, okay, but again we can simplify because it is belong on one single plane, okay. 750 is belong to one single plane, but the single plane is that involve two components, okay. 500 Newton is single plane as well, but the force is belong to X component only. Okay, 750 belong to Z and also Y component. Okay, Li Jiaying? Okay or not? Okay, so let's proceed. Can you help me to simplify this equation? 4 over 9, how much?
0.444.
This one,
Yes.
TAC and I. How about This one 7/9.
0.77.
7/8.
Yes.
TAC. TA. And the last one 4/9. Same with X component 0.44 lah. TAC. G. Okay. So you have all those IJK form, then you can use the first equivalent system, the first three equivalent system, which is Fx equal to 0, Fy equal to 0, Fz equal to 0. Okay.
It is K or J, doctor?
Yeah, sorry. Thank you so very much. It is K. Okay. Great, great. Please say to me if I do wrong. Okay. Please say to me if I do wrong. Okay, for the first one. Okay, let me go back to the FBD. We do have 1, 2, 3, 4, 5, 5 unknowns, meaning that we have to determine at least 5 equations from equivalent system. Okay, so we do have 5 unknowns, means 5 equations. Okay, so the first 3 equation is coming from Fx, Fy, and Fz equal to 0. Let's do it. Let's do it. So Fx equal to 0. Okay, Fx equal to 0. You have to determine, you have to put this one, okay, as component, put this one as component, put this one, and this one. Okay, okay. Please recheck. If any wrong, please inform me. Okay, so I put 496. It is TAC, right? Sorry, TAB. TAB. It's TAB. Okay. And then plus 0.44444444. 4444 T AAC. Okay, in this solution, no need to put I because we already know this one is for the X component, which is I component lah. So no need to put I, just put the number, the unknown value. Okay, and then OX plus OX, and then minus 500, okay, equal to 0. Okay, and the second one is the Y component. So from here, the Y component, this one minus value, this one, this one, this one. So we do have 4. Okay, 8, 6, 8 TAB. Okay, then TAC is 778. TAC, oops, plus OY, and another one is plus 750 sin 60. Equal to 0. Okay, and the last one is the Z component. Okay, Z component. Z component, no Z component for the TAB, TAC, we do have this one and this one, only 3. Okay, minus TAC, 4444. Oops, TAC. And then plus OZ, 750 cos 60. Alamak, alamak. How much then? 750 cos 60. Okay, equal to 0. So from here you have already 3 equation. Okay, 3 equation. Okay, first equation, second equation, and third equation. Okay, we have to determine another 2 equation from the moment. Okay, from the moment. Let me check what time is now. Oh, near to 11 a.m. Okay, so this is your homework. I give you homework. Okay, you have to continue from here to determine another 2 equation from moment. Okay, then from there you can get the answer. Okay, let me give the idea. Let me give the idea. Okay, so the moment that you have to take is about 0.0 lah, of course 0.0, because they are the largest number of unknowns. Okay, so in your moment there are 4 actually, 4. Okay, 4. Okay, 4, which is this. I put it number 1, number 2, number 3, and number 4. So you have to consider 4 forces in your moment. Okay, and you have to determine R lah, of course. For the TAC, TAB, the R can get it from here lah, the easiest one. Okay, the easiest one, which is ROE is equal to 7G. Okay, same goes to others lah, because it is same point. Okay, this is the only R for all forces, for this force, for this force, for this tension, for this tension. Okay, straightforward. This one is straightforward. Okay, so the equation, another 2 equation can get it from here, which is ROA cross with 500. The first one 500 watt should be 500 I lah. Okay, this one is I. Okay, oops, sorry. Okay, plus ROE cross with 700. Okay, I put it like this 700 Newton. So you have to substitute 700 Newton, this one into the equation. Okay, and then plus ROE cross with TAC. Sorry. Technical error. TAC. And the last one is ROA cross TAB. Okay, so you will get two another equation from here. Okay, I think that's it. This is your homework. Please complete this one. Maybe next week we will discuss on the solution. Okay, all right. Any question before we end the class? Any question before we end the class?
Doctor,
Yeah.
for the moment, ROA cross with 500 I, do we need to put, do I need to put negative or positive or?
Which one, negative, positive?
No, 500.
No need.
No need. Just the negative.
Sorry, cannot hear you.
Maksudnya tak payah letak negatif positif lah, just 500 je.
Yes. Oh, sorry. This one is negative, right? Okay, thank you. This one, okay.
Yeah.
Yeah, you have to put negative here. Thank you for the question. Thank you for the question. You have to follow 100% from this IJK form. Okay, if the value got negative, then you have to put negative. Okay, if the value positive there, positive here, you have to put positive. Okay, same goes to here. Positive, negative, negative. Okay, so you have to refer back the initial IJK form. Okay, again, thank you, Haris. Haris,
Yes, doctor.
okay, okay. Any more question? Yes, same Biki, 750 should at Z direction. Why at Z direction? It should be Z and Y direction only. Sin Biki, 700 Newton is at Z and Y. There is no X. Simikin. Because the angle there, draw a plane like prone to X and Z direction. What do you mean, Li Jiaying? Okay, maybe you confused about the 750 Newton. I think I have to draw it like this. Huh? Or maybe like this. Huh? So the 750 Newton is belong to Z and Y plane. Y and Z plane. Okay. This is Y. This is Z. Okay. 750 Newton is belong to Y and Z plane. So that's why we do have Y and Z component only. Okay. All right. Great. Okay. So make sure that you see carefully. You determine carefully. Okay. So otherwise the answer will be wrong. Okay. To make sure that you understand, let me explain about 500 Newton there. Okay, 500 Newton is belong to Z and X axis, but the 500 Newton is only in line with X axis. Let me draw the plane. The plane should be like this from here. Oops. Nampak macam bodoh eh. Sekejap eh. Let me erase. Okay, from here to here to here. This is the plane. Right? This is the plane. So the plane is Z and X. Okay, at Z plane. But 500 Newton is in line with X axis, which is there is no Z component at all. Okay. So make sure that you understand the 3D 3D plane. Okay, any more question? Any more question? I believe that already 11 you do have class after this. Okay, no more question, right? Easy, right? Okay, if no more question, thank you so very much. See you on Sunday for the tutorial class. I will give the question before the tutorial class, then you have to solve it before the tutorial class. Okay, thank you so very much. See you on Sunday. All right. Okay.
Thank you, Doctor.
Okay. Right. Okay. Uh,